when we start looking at how this is implemented, we have rapid spanning tree protocol configured here. Now that means we were talking about this STP. So what I want to do is I want to take a look at this. So let's pick any one of these individual interfaces. So we'll go over to R2 or Cat2 because Cat2 is also in an STP state. So let's take a look at Cat2. Now the moment we do that, all we have to do is to show spanning tree, looking specifically for VLAN 1. And look at what we see here. We see no operational differences from what we saw before when we were running the regular old-fashioned per VLAN spanning tree plus. Now what I want to do is I want to illustrate, when you see the STP in the quotations, not in quotation but in parentheses, that tells me that I am communicating to a device that don't speak the language that I speak. So in other words, that's the backwards compatibility that we're seeing. So in other words, when you see STP, that's Cat 1's way of telling you, dude, Cat 2 don't talk rapid per VLAN spanning tree, it's only using per VLAN spanning tree plus. So I want to modify that behavior. So I'm going to come here and say config T, spanning tree, and what we're going to do is change its operational mode. We're going to say mode, and then I'm going to say rapid PVST. Do show spanning tree config. I was just curious about something. That's an MSTP config, but I didn't know if it worked. But what we can do is we can do summary. So do show spanning tree summary. Now notice rapid per VLAN spanning tree. Notice that we have all of these VLANs that we were creating. We have all of the information associated with them. Some of it's useful, some of it's not. But bear in mind that our routing protocols, our spanning tree protocols are backwards compatible with each other. Now, recognizing that fact, let's go back over to Cat 1 and see what happened with any type of changes. So let's just repeat the show command that we have. And what we're going to see here is that 23 and 24 are just straight point-to-point connections. When you see point-to-point, that's going to show us that that particular connection is operational and it's communicating to a spanning tree neighbor that speaks the same language as I do. Now, other thing I want to illustrate here is let's go down to interface FAO 23, and I'm going to say duplex half. Do show, actually I'll just see if I can't bring it up. Notice that's going to bring down my link. No, link will come back up. Now what I want to do is I'm going to look at it. So show, do show spanning tree VLAN 1. Now notice it went to shared. So it's the duplex state that corresponds directly to what mode I can come up in. See, now what happens here is I can't be in P2P, which means I can't communicate using rapid per VLAN spanning tree. I can't use rapid anymore on this link. So I can verify that by cutting over to Cat 2 and executing the show command, do show spanning tree VLAN 1. And what are we going to see? 23 is shared. I need a point-to-point connection in order to be able to use spanning tree protocol. Rapid per VLAN spanning tree protocol, excuse me. So what I need to do is I'm just going to remove that duplex configuration before it really starts barking at me. Do show spanning tree for VLAN 1. And dun, 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 we're just straight up and operational and point-to-point. Now, the issue here is we still were running rapid per VLAN spanning tree because remember, it didn't give us an STP, but we weren't able to get any of the efficiencies out of it. So when we come in here and I type show spanning tree, our options that we have are going to give us the capability of specifying details. Now, what I'm going to do is we'll just go ahead and just use details. And what we're going to see here, and I'm going to go ahead and get this chicken scratch off the screen. What we're going to see here is that for our ports, let's go ahead and find one of our link ports. Let's go down to something like 23 and 24. So there's 23, there's 24. So notice, the values are all pretty much the same. My cost stays 19. All of my calculations come into place. I have the same situation with regard to my designated bridge priority. I have the designated path cost, which is going to be the cost that my neighbor's advertising me to reach the root bridge. We have our BPDU sent and received. All right, now when we look at this, we haven't seen a whole lot of change. But let's see what happens when we come up here. So let's say spanning tree, path cost, and what I want to do is I want to say method, and what we're going to do is just specify long. I'm going to take it off. I just want to show the result of the command. So now if I come up here and say do show spanning tree VLAN 1, notice now we have the higher granularity with regard to cost associated by bandwidth. So in other words, it's no different between per VLAN spanning tree plus and rapid per VLAN spanning tree, whether or not we're using the 32-bit path cost calculation, the long method. Now, what I'm going to do is I'm going to turn it off before I forget about it, because we really need to make certain that that's standardized all the way across the board. And that should take us right back to where we were, where our cost calculations are operational. Now, what I want to point out here is the fact that I changed my cost calculation, but it did not force me to redo any recomputation at layer 2. Why? Because it's not a topological change. Since I have to remember to do it on all of the other devices, remember the root bridge or no other bridge in this environment sent any TCN notifications. Now, the thing that we need to recognize is that rapid per VLAN spanning tree, before I had a scenario where we had the devices that were interconnected, and I lost this link, and this device actually sent information here and here. This device would have sent it here, but the moment it arrived on the root bridge would compile and send a topology change notification that would in turn be flooded to all devices in my infrastructure. What ends up happening when we have rapid per VLAN spanning tree is that any device in the topology, as long as it's synchronized, is going to be able to initiate this TCN. So again, it's another efficiency with regard to ensuring that our processes work exactly the way that we want them to. Now, lastly, I need to go ahead and just do the marrying configuration on the other devices so that we have everything up and operational the way that we want it. So that's going to be spanning tree. I think I've already done this one, but I'll go ahead and do it again. So spanning tree, mode, rapid, config T, spanning tree mode rapid, 4, config T, spanning tree mode rapid. Make sure I did it on 1, which I did. So with that done, show spanning tree for VLAN 1, and we have our configuration. Now right now we have an issue here. FAO 14 tells me that I'm connected to an STP peer. So let's see what's going on that device. So show CDP neighbor interface, fast Ethernet 014. See what we're connected to. Well, here we're connected to a 3560 local 14 to 14. This says we're connected to Cat 2. So we have a link between Cat 1 and Cat 2 using port 14, which is news to me. So I'm going to turn that off. I don't like that. Config T, interface FAO 14. Anybody else that's got a rack open, can you verify to see if you've got a link between Cat 1 and Cat 2 using Fast Ethernet 14? Just out of curiosity's sake, I thought there were only supposed to be 3 connections between 1 and 2, and that was supposed to be gigabit. So if you could just check that for me, it'd be greatly appreciated. All right, so we have covered everything we really need to talk about rapid pure VLAN spanning tree. We need to look at MST. Now, multi-instance spanning tree changed the rules. And the rules changed because the industry standards body finally woke up. So like I said, let's follow the rest of our logic. The industry standards body created 802.1W. Now Cisco said, okay, that's fine. We'll take 802.1W, but we're going to do it in the form of rapid PVST because we want to keep these VLANs. And then along came a minor or a major change that entered the arena: voice. Voice is very interesting for us because what voice did is voice drove home finally the concept of a VLAN. If I can have a VLAN that allows me to be able to run voice and keep it separate from the rest of my traffic, that is a good thing. So the industry said, okay, well, all right, finally, after several years of this war that I've been describing, The industry standards body looked at the VLAN configuration and said, all right, we like that idea. We can recognize the fact that now we have the need for this. But this idea of having 4,094 of these bad bears is just still insane. So what we're going to do is we're going to create a new protocol called MST. Now MST is bounded by the standard for 802.1s, Sierra. So I just remember the MS and the S, and that helps me keep it in mind. I don't have a funny mnemonic. Well, hopefully what I thought you thought was funny. Mnemonic for remembering it, like 802.1W for WAPID. So what happens now is the standards body came up and says, okay, we're going to embrace VLANs. But we hate Cisco. We're not going to call them VLANs. We're going to call them instances. And what ends up happening here is we're going to start with an instance of 0. All devices are all VLANs in the Cisco deployment are going to automatically exist in MST0. Now, in order to be able to do this, there's going to be some configuration requirements that we need. First, what we're going to do is we're going to configure a name. We're going to configure a version. Then what we're going to do is we're going to assign instances. What is an instance? Well, in the terms of MST's implementation on iOS, an instance is a group of VLANs. Now here's the problem. We have switches. Our switches can be interconnected, obviously via trunks. And what we want to do is we want to have one homogeneous MSTP domain. Now the issue here is that I have the capability of doing individual configuration inside the context of each of these devices. So when I do my MST configuration, I create, say, VLANs 10, 20, and 30. 10, 20, and 30. 10, 20, and 30. Now what I need to do is I need to actually assign these to an instance. Now by default, every VLAN on a system is immediately going to go in instance 0. Now here's the caveat. The reason that we do this, the reason that every VLAN automatically goes into instance 0 is so that we can create this idea of an independent single MST domain. Because the name, the version, and the instance to VLAN mappings have to match. If they don't match, if they're non-congruous, then what ends up happening is we have separate regions. Now I used MSTP domain. What we really would call that would be an MST region. So anytime we have a difference of opinion regarding the name, the version, the instance to VLAN mappings, what's going to end up happening is we're actually going to have different VLAN or different regions. Now here's the situation. What happens if that's the case? What happens if I have Cat 1, I have Cat 2, I have Cat 3, and they're all interconnected, again, via trunks. And I have 10, 20, and 30 here. I have 10, 20, and 30 here. I have 10, 20, and 30 here. And in this instance, what I did is I left everything in 0. Instance 0. Here I left everything in instance 0. Here, what I ended up doing is I left these two in instance 0, but I moved this one to instance 1. Now what that means is that these two devices, since all of that information were to match, obviously we're assuming the fact that Cat 1, let me do this, Cat 1, Cat 2, all have the same name and the same version, so they match. So if the version and the VLAN to instance mappings match, what happens is these two devices create or operate in their own MST region. However, the problem is this device is in its own MST region. So we've got region 1, and then we'll just say, for the sake of argument, region 0. Now, the way this is going to work is inside of this region, we're going to have absolutely no issues communicating with each other. However, what we're going to find is if we're going to communicate between these regions here, now what we're going to do is we're going to have to do some games with information. What's going to happen is inside of this domain, we're going to elect a root bridge. inside this region. And by electing that root bridge, we're going to have this root bridge here. And what's going to happen is that everything inside this MST region is going to represent themselves as one virtual switch. Same here. Between regions, I'm going to represent myself as one virtual switch. It doesn't help that I am one virtual switch, but the whole idea here is that it's what's going to end up happening. So the exchange of information is basically going to take place between the roots in these particular configurations. Now, how do we make these configs? And like I said, we also have that instance to VLAN mapping. To VLAN mapping. Now remember, this is one way that I can take devices that are running MST, and what we're going to do is that we're going to do this to where we're going to have instance 0, which is going to have all VLANs by default. If I want to create others, then what I have to do is I have to take them out of instance 0 and put them in another instance. Now again, we want to make certain that these match device by device. Now, that's going to allow me to have the ability to be able to create my region. Now the other thing that we also need to point out here is that this is also going to be, just like rapid per VLAN spanning tree, backwards compatible. Now what will happen here is let's imagine that we have 3 devices. They're all interconnected. I have another device that's connected over here. These devices are in one MST region, let's say MST1. These devices, or this device, is in MST2. That's one way that we can communicate. Remember, we elect a root bridge and we're going to communicate with the other root bridge. All of our data is going to move between these 2 devices. This entire area is going to pretend that it's one virtual switch. But what ends up happening here is if I have another device that's connected, and this device is not running MST at all. This device is running rapid PVST. Or it's running regular PVST plus. Well, what's going to end up happening is the exact same process. The root bridges are going to communicate with each other, and what we're going to have is we're going to have one holistic layer 2 environment that's going to allow us to move data back and forth. However, we're going to have a mixture of our compatibility with STP, and we're also going to have the communication that's going to be taking place here. So at the command line, how do I configure it? Well, first, what I got to do is take all of my devices out of rapid PVST. But what I'm going to do is this. I'm going to make my life very easy. Exit, and I'm going to say no. Actually, we've already got VTP running, so I don't even have to worry about it. So what I want to do is I'm going to say config T, and then it'll be spanning tree MODE, and it's going to be configure it for MST. But before I do that, what I want to do is I want to configure it. So I'm going to say spanning tree MST config. Now you'll see I'm in an MST sub-configuration window. Now looking at this, I'm going to use help, and I want to see what we have. We have revision, we have name, and I have instance. We also have the capability of running private VLANs in the confines of MST. We'll talk about that on a side note when we talk about private VLANs and security. But all I want to do is I want to get my basic configuration in place. So I'm going to say name, IPexpert. I'm going to say revision 1, but notice we can take it all the way up to 65.536 or 535. So we'll say revision 1. Then what I'm going to do is I'm going to leave it alone. I'm going to say do show history. Actually, I'll exit first. Then do show history. What I'm going to do is I'm going to copy this to every other device in my infrastructure, or all of the devices in my infrastructure. So we go to 2, paste, 3, paste, and 4, paste. This is a perfect example of how we can set this up and use things like Notepad or show history in order to be able to copy information between our devices that's like for like. So now if I come in here and I do show spanning tree, do show, and I want to look at the summary of my spanning tree, everything's good to go, right? Wrong. I'm still running rapid PVST mode. And a lot of students make this mistake in labs, in like mock labs that we teach and everything along those lines. And the primary thing that they forgot to do is they didn't enable MST. So there's one additional command that we need to configure once it's set up, and that's going to be spanning tree mode MST. Now the moment we do that, now we've got an issue. On Cat 1, notice I'm currently running MST. Now when we go through here, look, blocking designated, blocking to, that's 21, 22, 23, 24, 25, 19, and 20. So it's inconsistent superior PVST BPTUs. So let's see what's going on here. So when I come in here and I type do show spanning tree for VLAN 1, let's see what we see. Okay, well looky here. We've got all kinds of stuff going on right now. So this connection over here is showing up as STP. I have no idea. I really don't understand why this is hooked up. So let's pay attention to 19 through 23 and 24. Notice right here it says we are point to point, we are bound, and what we're doing is we're communicating STP across this link. On these links, we're all communicating to per VLAN spanning tree. Notice it doesn't say the idea of STP here. And we have this process where we're going through learning. Let's see if it ultimately cooks out. Everything goes to forwarding. The moment I see everything that is forwarding on this device, I know beyond a shadow of a doubt that I am going to be operating, let's see, double check that, make sure I'm not talking out of school. Forward, designated route. Now, the point is that when we were talking about STP, remember I told you that the root bridge was always going to have all of its ports in designated. This one has a root port, so that tells me I'm not the root bridge. I'm connected here on 14, and as we said, I'm going to disable that because that is a freaking nightmare. Just give me one moment. Interface FAO 14 shut. I'm going to go over to 2 and do the same thing. I thought I already did. FAO 14 shut. Now let's go back over here to Cat 1 and see if we can refresh this thing. All right, there we go. This is what I was looking for. Look what's happening here. We have all of our configurations in place, but notice we've got a simulation inconsistency cleared on this port. So what's going on? Notice we have PVST inconsistent state. Now over time, that should cook out, which as we see it did. Now when we see we're bound PVST. Now if I go over to Cat 2 and I type the same command, do show spanning tree for VLAN 1, what am I going to see? Well, I'm going to see, first and foremost, that we're running rapid per VLAN spanning tree. So I need to enable this on all of the devices in my infrastructure. Spanning tree mode MST, spanning tree mode MST, and spanning tree mode MST. I'm sorry, I keep using shortcuts. I'm trying not to. So, I mean, if it starts getting really bothersome, just remind me. So now let's take a look at this. And we'll do our idea here of show VLAN 1. And now notice we're all just straight point to point. Now, when we look at this, what ends up happening, like I said, one device among all of our MST speakers are going to come in and it's going to be operating as the quote-unquote root for the entire region. So how do I know how it's configured? I can come in here and type show spanning tree MST configuration, and it's going to tell me exactly how it's configured. Notice right now my name, my revision, and notice my VLANs that have been mapped. Now, we talked in passing about VTP version 3. VTP version 3, one of its most handiest advantages is it allows me to use VTP to communicate and synchronize MST information. So what VLANs are assigned where? Manuel is asking, can you take the moment to explain the process of adding a new VLAN after MST has been configured and the impact to spanning tree? Most definitely. That's what I was getting ready to do. Because what will happen is that initially there will be no impact. Because the moment I create a VLAN, it's immediately going to participate in VLAN 1. But let's take a look at it and see what's happening. We'll just do it on one device first. Actually, I have it on Cat 1, so it'll get propagated via VTP. So I'll create config T. And we've got the devil's VLAN, so may as well create heaven's VLAN. So we'll say 777. What happened, William, is the instances were done automatically. We have instance 1. Hold on just one moment. We have instance 0 was automatically, every VLAN was mapped to it. So we don't have to manipulate it. And that happened on every switch that we have running MST. Now I'm gonna mess with it. Let's first of all create MST or VLAN 177. And I'll come over here to Cat 4, do show VLAN brief. See if 777 is in the mix. There it is. All right. So, yes, by default, everything is going to go to instance 0. Now, if I came in here and said no spanning tree, or actually what I'll do is I'll go under the configuration here. I'll say config T. I'll say spanning tree, MST config, and I say no MST 0 or instance. No instance. And I'm going to say instance 0. It's not going to let me delete instance 0. Instance 0 is very much like VLAN 1. Now I can create a new instance. I can say instance 1, and what I want to do is I'm going to use context sensitive help, and I can now assign VLANs to this instance 1, and the one that I want to install is going to be the heavens VLAN. So now we've got a situation. What is that situation? Exit, show MST, show spanning tree, MST, detail. That's just going to be the add-in information. That's not what I want. Where is it? Is it service? Instance? Nope. We'll just look at it on the table. So here what we do is, show VLAN. But I want to do instance now. So I want to say show spanning tree, MST 0, and let's take a look and see what's going on. Well, for MST 0, I'm going to go ahead and I'm going to erase this right here. And let's look at this output. Now notice it's giving us quite a bit of stuff. It's telling us, all right, here's my address, here is my priority. Notice I have a system ID, which is the equivalent of the extended system ID in the confines of PVST. And what we're going to do is, in this instance, the system ID equates to the MST number. So in this instance, it's 0. Therefore, it's going to be 32768 as my bid. Now, when we look at this, we have an operational configuration of 2, 15, and 20. And we have a configured of 2, 15, and 20. What we have to understand is these processes are going to be negotiated between the devices based on how they're configured. And William's saying, so if I had 100 instances with VLAN 1 hundreds, it would be PVST. Basic is the performance. The default, the way Cisco created it or implemented it on iOS, is that behavior pretty much defaults back to common spanning tree or PVST, where everything's operating in one VLAN. So to modify that, if I had 100 VLANs, to add to what William's saying, if I created 100 instances, what would end up happening is I would get the same results as PVST+. Now the problem is with that logic. So let's look at that. When I come under the system, config T, and I type spanning tree, MST configuration, and I go and I create my instance, I'm going to use my help. Notice here I had the capability of creating 4,094 instances. Can you guys test that and see if it shows up in your gear? Because I think that's a modification on the 66 code. Because at one time we could only have 16. At one point there was 8, and then there was 16, and I think they were talking about raising it to 32. So if you guys could check that out for me, it'd be greatly appreciated. When you go into the spanning tree MST configuration, what's the maximum number of instances that you can have? You can't use special characters. Okay, you have 4096, Jeffrey? Can you just show version and tell me what version of iOS you're running on that device? Okay, cool. So everybody's saying that they have 40942. I just wanted to make certain that it wasn't an instance. So when we are variations in platforms. So right now what we have is we have a configuration. I'm going to go ahead and clear this, and I'll go back to the whiteboard. We have a configuration where we have Cat 1, Cat 2, Cat 3, and Cat 4. And what we've got is our interconnections, and we're using all of our links. So that's the doubles. I'm using that as representative of the doubles. All right, so everybody's got 4094. That's good to know. Thank you. Now, what we see here is that we have configured the system to where these three switches are in one MST domain, but this switch is in a separate MST domain or region. So let's look at this. So from the point of view of Cat 4, what happens when I do my show commands? So on Cat 4, show spanning tree, or show spanning tree, MST 0. We'll go ahead and hit it, and what we see is exactly what we expected to see, that we're all operating. Now, what we see here is root. This switch for the CSIT. What does that stand for? CIST. Domain equals region. Yeah, I'm incorrectly using the term. I apologize. I keep trying to force myself to say region. What does CIST mean? Let's take a look at some of the other devices. So if I go up to Cat 1 and I say show spanning tree MST 0 and I hit enter, notice right here, regional root is this switch. So we've got CIST and we've got regional root. So what this is indicating is that in the confines of Cat 1, Cat 2, and Cat 3, this device right here, the root, we are going to be the root of this configuration. So this switch, 7180, is the root bridge for this entire region. Now what we also have to look at here is what's happening on the other side of the equation. So 0, not 0, Cat 4. Now Cat 4 is interconnected. Let's take a look again at Cat 4. We should have the show command up here. So notice what ends up happening here is it's saying the root for this CIST is this switch. So all that's saying is it's common spanning tree, it's common instance, the common instance spanning tree session, which is going to be I'm standalone. So there's no other devices, so I am the root. Now what's happening is this root and this root, like we said earlier, are going to be exchanging information because these three devices are going to pretend that they're one virtual switch. All right, so let's take a look at the rest of this. Now let's go over to Cat 1 and take a look at see what we got. Now remember, Cat 1 has a diagonal connection down to Cat 4. Show MST, show spanning tree, MST 0. And what I also want to see is MST1. We don't have an MST1. So looking at this, show spanning tree, MST configuration, notice we have all of our instances are mapped to 0. Do I have show VLAN 777? Show VLAN brief. Sorry. 777's right here, but it's in instance 0. So the moment that I start making these changes, what I'm going to do is I'm going to go to Cat 3. I'm going to have the two on the top be in one MST instance and the two on the bottom be in another. So to do that, all I'm going to do is go into spanning tree, MST configuration, and I'm going to say instance 1 VLAN 777. Exit, exit. Now, 3 and 4 should be in the same instance, and 1 and 2 should be in the same instance. So let's verify that. So let's say in show spanning tree MST 0, hit enter, and I'll clear out all of my scribble here. And what do we see? We see now that we have a regional root address that is 7180. We see the priority there, and we also see our device, we're 6100. The root bridge for this group is 7180, and he's acting as the root bridge for the entire region. So now what ends up happening is we have the two regions where we have a root bridge and a non-root bridge that are connected. Bear in mind, we're cross-connected out the wazoo, but the whole idea here is never lose sight of the fact that it's going to be these two switches that are going to be responsible for the exchange of information. So now notice we don't have a CST configuration here. Why? Because I'm in the same configuration. But let's cut over to the other one. So let's cut over to 4. Actually, I need to grab my arrow. Let's cut over to 4 and repeat the command. This switch is for the CIST. So that's the root of our region. We see here it's operational. Notice the bridge that we have, other devices that we're connected to. If I had multiples, we'd be able to see each one of them. So CST as one switch is region. Pretty much, yeah. The idea here is that what we're going to do is we're going to have a CST, and the CST, or the CISTs, are going to be responsible for communicating with each other. It just so happens that the CIST, by default, is going to be the root bridge of the region. All right? Now, with that being said, we need to check out one other element, and then I'm going to put you guys back into labs. All right, what we want to do is we need to recognize, first of all, let's get everybody set up to where they're in the same region. So I want to be able to see more than just two devices. So we'll say spanning tree, MST config instance 1 VLAN 777 and 1. Config T. Spanning tree MST 0. Sorry, MST configuration instance 1 VLAN 777. Show show spanning tree MST 0. Okay, now notice we see the information here. We've got the bridge, that's us. This is the root. We see the regional root address is 7180. That's going to be whatever device that is that we're connected to, 700. But notice right here we see some information. So let's wait and see if that actually goes away. Well, 21 and 22 are still listening and learning. Everything seems to be still converging. So let's wait and see until everything comes up. There we go. Now, it's these instances right here where we have a dispute. MST is going to do things. It's going to block information. It's not going to accept stuff, and it's going to be, by its very design, able to stop an interim or a transitional loop at layer 2. Now, there are other technologies that we can use to do that. I mean, the data center technologies, the biggest one is BA, Bridge Assurance. Bridge Assurance allows us to be able to use BPDUs to exchange information, and through the exchange of that information, I can detect whether or not a VLAN's active on another end. I can actually bring everything down. But the same point is Bridge Assurance is very much like the concept of our keep alives that we were talking about, or we did talk about when we were working in version 4 with Frame Relay. We're going to be using BPDUs for the purposes of sending information back and forth, very like we do loop guard configurations. So just keep that in mind. I mean, it's not our only solution, but MST does give us a lot of advancements. The other thing that I want you to keep in mind here is that MST not only does that, but when the industry standards body created Rapid PVST, when Cisco created Rapid PVST, and then the International Standards Body came online and said we have MST. What they did is they took all the cool crap in 802.1w and they just folded it under MST. So MST, remember, what we had is I had MST running, and MST was actually connected to a backwards compatible link running rapid per vLAN spanning tree, and instead of coming up and saying STP, it had the idea of PVST in those parentheses. Now the parentheses indicated what type of device that I'm talking about. So if I'm backwards compatible with a PVST device, it's going to say STP. If I'm backwards compatible with a rapid per VST, it's going to say PVST. All right. Now the only other thing that I wanted to talk about, I'm going to talk about in passing, and that is going to be, actually we'll do it over here. We need to talk about lags, link aggregation. Now, in the CCIE routing and switching version 5, we only have one tool, which is going to be a port channel. Now when we configure these port channels, they can actually operate either as layer 3 or layer 2. They can be layer 3 routed, IP enabled. They can be layer 2 access ports. They can be layer 2 trunks. Now why do we use these? Well, what ends up happening is that we're going to have to first recognize what it is we're trying to accomplish. When we take two devices, so let's say I have SW1 connected to Cat2, told you I'd slip, with multiple links. We already talked about what spanning tree is going to do. Spanning tree is going to come up here. It's going to say, okay, I'm going to disable this link. I'm going to, everything being equal, I'm going to use the link with the lowest port number. So in this instance, let's say 23 and 24. I'm going to block the port that's the highest number by default, just simply because it's the tiebreaker that we have. And then what we're going to end up doing is that we're going to lose throughput. So let's say this was 100 meg. Well, we lose 100 meg. Yes, Curtis is asking, does anyone run MST in production? Almost every one of my clients run MST. And I have pretty dense instances where it's all Cisco gear. A lot of pharmacies, a lot of hospitals, a lot of the enabled emergency rooms, as well as a lot of the consultancies that I work for run MST. So you're definitely going to probably see it, probably. It's more than likely that you're going to see it in live environments because it is pretty common. Yep, and that's the primary reason. Avery's bringing out the fact that they run MST in conjunction with other vendors' switches, and that's one of the primary reasons that we're running into it. It's also one of the reasons that ISL went the way of the Dodo, since it's just a Cisco proprietary solution anyway. Now, looking at this, what we want to be able to do is we want to create a scenario whereby we can use both of these links. And that's going to be through the concept of Etherchannels. Now, Etherchannels are weird ducks, because what we want to do is we want to make certain that the base interfaces, so the member interfaces that we have in our port channel configuration, we want to make absolutely certain that those interfaces have matching config. If not, default those bad bears. Because if you bring up a port channel and you have mismatched configuration, mismatched speed, any other configures in there, what's going to end up happening is this thing's going to crash and burn, and you're going to have huge problems with your Etherchannels. Now, what I always say is order of operations matters. Now, I have my own way of doing it. You may build your own, but I don't have problems with my Etherchannels, but I do them differently for layer 2 versus layer 3. So what we want to do is let's dive into the equipment and see what goes into creating these. So what I'm going to do is I'm going to cut on Cat 1, show, we don't even have to do it, it's right here, show MST0. We'll leave MST on, and what we see here is 23 and 24 are operating, and here notice we're forwarding and forwarding. But if I cut over to SW2, what we're going to see is 23 and 24 do show spanning tree MST0. Notice that 23 and 24, according to this, they're both blocking. And I'm using gigabit 01 as my root. I want to get rid of that. So exit instance or interface G01 shut. So let's repeat that show command now with that shut. So 21 leads me to the root. So do show CDP neighbor FAO 21. That tells me that my root of my entire region is cat4. So let's see here. Show spanning tree MST 0. This switch for the CIST. So looking at this, what we see is all of these interfaces are designated. So what I want to do is I'm going to pick one or two of these, and what we're going to find out is how things are actually working. Now that we got that gigabit interface out of here. So which one of these are connected to Cat1? So show, run, interface. No, we'll do Cat2. Show, run, show CDP. Neighbors, pipe, include. The only thing that I want to see is Cat3. So that's 23 and 24. So on this end, they're both forwarding. But if I cut over to Cat2, sorry, Cat3, if I cut over to Cat3, so from Cat4, everything's forwarding and I'm the root. So let me go ahead and draw that out. So from Cat4, I'm the root bridge, and both my links, 23 and 24, are forwarding and designated. So that means I'm looking at my connection right now to Cat3. On 23 and 24, what we're going to find here is that 24 is going to be blocking. Let's double check that. So over here on Cat3, what we're going to see is 23 is the root port. So that's the port that we're going to use to reach the root bridge. And we see, just as I said, 24 will be blocking. Now, the problem here is, like I said, the additive throughput on this thing, it would be really cool if we could take these interfaces and gang them together. And that's what lags are. That's what our link aggregation protocols are going to do for us. Now, we have to recognize that there are two flavors. There's the industry standard LACP. Stands for Link Aggregation Control Protocol. There's the Cisco proprietary version, which is called PAG-P, Port Aggregation Protocol. Now, when we do this, we're going to find that there's going to be different terms that we use, but the whole thing is that all of these methods are dynamic in nature. Now, when I run dynamic, I also have a way of doing this via static. Now, the benefit of having dynamic is that I've got a control plane mechanism running in the background that's going to monitor this and make sure that everything is up and operational the way I want it to be. If I am running static, I'm pretty much hit or miss whether or not I've got my configurations done and configured properly. So what I want to do is I want to walk through this process right here and set this up, and I'm going to do it on this link between 23 and 24. And like I told you, we want to make certain that our link configurations are the same. So if I do show run interface FAO 23 to 24, and I can't do that, I'm not on an XOS. What we see is 23 is configured for switch port trunk encapsulation.1Q, switch port trunk encapsulation.1Q. Everything's good to go there. They match. So all I'm going to do is I'm going to say interface range FA0 23 to 24, and I'm going to come in here and I'm going to say channel group. I'm going to give it a number. So what I'm going to say is, since this is connecting 3 to 4, I'm going to say channel group 34, and I'm going to say mode. And the mode that I'm going to specify right now is on. On means I'm going to use static communication. Now, when I go through here, if I want to use LACP, I use active and passive. If I want to use PAG-P, I use auto and desirable. I always think of this in terms of the fact that PAG-P is Cisco proprietary. And on Cisco proprietary links and trunks, the way they deployed it is they have active and, they have passive, they have auto and desirable. So remember, our dynamic mode's auto, dynamic mode desirable. So auto and desirable is going to be Cisco proprietary PAG-P, and active and passive is going to be LACP. And the moment I create this, I hit enter, what's going to happen is it's going to make a new interface. Do show run interface PO34 for port channel 34. And notice it copied all of the configuration off of the individual member interfaces. This is exactly why we want to make certain that the config is the same, because if there's a configurational mismatch, this process is going to fail. Now, the other thing that I want to point out here is that when you do this, we have some way of checking the status of our connection. So show Etherchannel summary. Notice here we have PO34 SU. S stands for the fact that I am switching, layer 2, and the U stands for the fact that I am in use. We also see P. P means I'm participating in the bundle. So I've got member interfaces, and those member interfaces are working. The problem is it's not configured on the other side. So let's take a look at the status on the other side. So here we type show Etherchannel summary, and I have nothing. So when I cut back over to Cat3 and I do a show, here's where we're going to start getting yelled at. Do show, or show, spanning tree for VLAN 1. Notice I don't have any of the interfaces. I don't have 23 or 24, and I also don't have that PO34 right now. So it was taken out of the equation. And what we want to look at right here is something that is on by default now in our more modern versions of the iOS. This is a feature called channel misconfig, or Etherchannel misconfiguration. And what happens is it's running, and so what it's doing is it's actually error disabling our configs. Now if I wanted to turn this off, all I have to do is type no spanning tree, Etherchannel guard, misconfig. And that's going to turn this feature off. Now the moment that I do that, that's not really going to help me too much. Show Etherchannel summary. Notice it's D. My states went down to D for down. So what I'm going to do is I'm going to bring them back up. So interface PO134, PO34, shut. No shut. And let's see what happens now. I do not ever recommend, unless you're instructed to do so, to turn off the Etherchannel misconfiguration feature, because you can find yourself in some pretty hairy situations, especially if you're using static port channels. Do show Etherchannel summary. So notice now my ports are still in P. Do show spanning tree for VLAN, or for MST0. Now notice my PO is here. My PO thinks it's up and operational, and we're able to send information. Now this is definitely something that you want to do. William, if you like to love dangerously, I don't know what to tell you, man. Yeah, I think he meant live dangerously. So looking at this, we have this scenario now where we have a problem, because what happens is it's configured on this side, but it's not configured on this side. So now I'm forwarding information that's arriving on these links, but these links don't understand what it is that I've got configured. So what I want to do first of all is I'm going to show you again the fact that I can re-enable this process, because I again don't want it turned off. And now notice it went to down. Now let's take a look at our status. Show Etherchannel summary. See, there's still P. So my interfaces 21 and 22 are down, but the connections are still up. It says they're bundled. Where if I come in here and say spanning tree, Etherchannel, and it's going to be guard, misconfig, and hit enter, what it will ultimately do is it'll bring my links down. Misconfiguration guard for Etherchannel is on by default on our devices. Now also notice here that this is also seeing the fact that we're seeing MAC flapping. So again, this is all made part and parcel by CDP. We're learning all of this information. So config T, interface, do show run interface, FAO 23, 24. Do they match? Yes, they have matching configurations. Interface range, FAO 23 to 24, switch for channel group. Channel group. I'm going to pick another number. I'm going to say 43, mode on. Oh. Channel group 43 mode on. I don't know what I was doing wrong. All right, so look at this. Let's see what happens. Do show ether summary. Now we're up and operational. Now, the ether channel misconfiguration is going to do a number of things for us. It's going to prevent us from having problems. What if our connections were cross-connected? What if they didn't go where we wanted them to? What if for the brief instance of time we had the capability of having a transient loop form in our environment at layer 2? These are all things that we use ether channel to eliminate. Now the other thing that I wanted to point out is that we also have the capacity of being able to create this as a layer 3 link. Now the layer 3 link is a little bit different with regard to process, with the way I do it at the very least. And again, if I do something one way does not mean that you guys have to. You're going to have to figure out what works best for you. But what I want to do now is I want to do show run interface FAO 0, 23, and 24. And these are operating as layer 2 interfaces, and I need to change that. So what I'm going to do is I'm going to say config T, and I'm going to default these interfaces. So I'm going to say default interface FAO 23.2.24. Then what I'm going to say is interface FAO 23.2.24 range. Like I said, NXOS ruined me. And then I'm going to say channel group. And we will say 12 this time, mode. And this time I'm going to do LACP. So I'm going to say active. So active and active will form a link. Active and passive will form a link. Passive and passive will not form a link. So we'll fire that bad bear up right there. And what are we going to see? It says 24 and 23 will be suspended. Trunk encapsulation of .1Q FAO 23 is auto. So our link state changed to down. Now what I've done is I've intentionally created a scenario where we've got a problem. I can't bundle these interfaces. I can't bundle them. Let's look at see why. Do show run interface FAO 23, FAO 24. All right, 24 didn't clear. So let's go ahead and do this. I'll clear them all. Exit. Default interface range FAO 23 to 24. And now it'll clear everything. Do show run interface FAO 23. Do show run interface FAO 24. Now they both should be gone. Trying to delete commands from the parser. Now we'll be able to do it. I'll say interface FAO range FAO 23 to 24. And I'm going to come in here and I'm going to say switch port or channel group 12 mode active, enter. Now it'll be able to do it. It also will create that port channel interface that we were talking about. So any moment now I should get a message that says PO12 was created. Oh, it already created it when we accidentally did the config. Do show run interface PO12. Yep, already made it. So if I come in here and say interface PO12 and I say no switch port, notice it says it rejected the command, not a convertible port. Now what I have to do is I needed to do the configuration under the range command. So if I come up here and I had done this and I had configured interface range FAO 23 to 24 and I said no switch port and entered it here, do show run interface PO12, what we're going to see is the fact that ultimately it should negotiate it, or it should have it set up. So let's see, do show run interface FAO 23. Now notice the problem. See, I created everything out of order. So here I've got no switch port, I've got no IP address configured to this, and notice what it did. The moment I typed switch port, no switch port, it removed all the configuration under these particular interfaces. If I repeat this for 23, do show run, I'm sorry, 24, do show run interface FAO 24, we're going to see the exact same thing. So that's not what we wanted to do. So let's default them again. Default interface range FAO 23.2.24. They're defaulted. Interface range FAO 23.2.24. What I would do, the way I do it is I would type switch port, or I would type no switch port. And I'm going to give them another number because I don't want to use the one we have. I'll say channel group, and we'll say 21, mode active, no shut, interface PO 21, IP address 10.1.10.10.7.255.255.255.0. No shut. Show IP interface brief. And we're going to see that I should have at the very bottom of this list a functional port channel with an IP address assigned to it, which I do right here. But it's not up. Why? Because the link's not up. William, we don't need to enable IGP routing because we're not going to be doing routing. If I wanted to route between VLANs, yes, I would have to. So all I'm going to do is just enable a reachable IP address. Notice it's not participating in a VLAN. So I've already got interfaces for my loopbacks, so it's just an issue of configuring. I'll be able to ping. You'll see what I'm talking about. Now when we go through here, it says now that they are suspended. They're suspended because it's not configured on the other end of the link. So let's go ahead and do that matching configuration here. So I'm going to say interface range, FA0, 23.2.24. I'm going to say no switch port. That's going to replace all the configuration anyway. Then I'm going to say channel group 21. They don't have to match. I just always do it to make my life easier. Channel group mode active. Hit enter. No shut. Interface PO21. IP address 10.10.10.8/24. No shut. Exit. Show port channel, ether channel. Summary. And what we're going to see here is the links. We've got LACP running. We have 23.24. Let's take a look and see what we have running over here. Do show ether channel summary. Up and up on both sides. Now here's the scenario. On both ends of this link I have two modes that I can have. I have active. I have active. On both ends of that link, this is going to create a link. I have active, passive. Link will be created. If I have passive and passive, no link. If I'm using PAGP, Cisco proprietary solution, if I'm using that and I bring my link up, I have desirable and desirable, I get a link. If I have desirable and auto, I get a link. If I have auto and auto, I do not get a link. Now that also means that I have also on. On and on will give me a link. On in any one of these other modes will not give me a link.